We continue our live stream on the editing of the Sunset Way running videos for Singapore Frontrunner. Today we will begin our work on the second part of the Sunset Way run videos. We created the first part in our earlier live stream. The music as well as the video, and we published it on Instagram. Today we will start working on the second part, the second and final part of our Sunset Way run videos. But before that, let me talk about something interesting that I've been exploring for the next batch of videos. Not a Sunset Way run, but maybe the next one for Sungai Bedok. Let me explain what the problem we have today and what kind of opportunities we have for making this problem go away and get better. Let me pick up the video that we have uploaded on Instagram. That is a Re1.mp4. Now notice that one of the problems you always have with the Insta360 X5 camera is that we always have too much sky in the video. In this particular video, we have sky at the beginning, and we have, again, lots of sky in the end. Right? The reason for this sky appearing is that we wanted to use this semi-distortion format to show as many people as possible within this narrow frame. But then we cannot show too much of the ground because then my hand that's holding up the camera will be visible. Therefore, we adjust the tilt of the Insta360 reframe plugin in such a way that my hand isn't visible. But then we end up with a lot of sky. Now, I have a suggestion for making productive use of this space here, and also to make our videos more engaging. What I propose to do is to add in a 3D map of our running location. This video begins at Queenstown MRT. That's the Queenstown MRT station. Why don't we include a 3D map at the top that will show us the location of this MRT station on the map? Which means that as this video begins, eventually for next batch of videos, we will have a 3D map that's superimposed there. A 3D map that will zoom in, rotate and zoom in slowly into the map of Queenstown, zooming into the Queenstown MRT station, and maybe a big purple-pink drop that will fall down from the top and land on the precise spot of the Queenstown MRT station that we are starting our run. Right? We can do the same thing at the end of the video. At the end of the video, yes, we'll keep the initial part of the scenery. But then as we head towards the end, we can slowly bring in a 3D map again that shows us the final location of the run, where the run ends. In this case, Sunset Way. We will have a 3D map that shows Sunset Way. And why don't we show a plot of the run from Queenstown MRT all the way to Sunset Way. It looked a bit like Strava, but maybe a little more nicer, a little more slick version with 3D graphics. Yeah, that could be one interesting way to fix our too much sky problem. We have too much sky at the top, at the end of the video. We had too much sky at the beginning of the video. Also, it gives some nice context. We will know where exactly we started the run. Maybe people from other countries will not know where Queenstown MRT station is, but at least with a map, it gives more context. And towards the end of the video, if we show the map with our running trail, then we have a good idea how far we ran and what kind of terrain we ran through. And we could animate the run on our 3D map, maybe by using, again, smaller purple pinkish dots all the way to, and then you have two large dots, one at the beginning and one at the end, right? This is just an idea that I'm having for the next batch of videos. Let me give you some hint about how it looked like visually. The way I'm doing this preview is with Unity. Yes, this is the Unity tool that many folks use for creating video games. The reason for doing this Unity is that it comes with this very neat tool called the Maps SDK for Unity. This is provided by Mapbox, which publishes 3D maps. Let me just do a quick demo of this Maps SDK. I have a demo that I've loaded into Unity. I will just click the Run button. I reloaded the map to center on Queenstown MRT, and it loads there. There you go. It's pretty neat, right? It comes with a base layer, and that's a satellite map of Singapore, and it allows you to zoom in. If I use my mouse wheel and I click on this and zoom in, if I keep rolling my mouse wheel, it will zoom in. This could be part of our animation. Our animation will be a 3D map of the MRT station. Maybe we could start with a satellite map without the buildings. Then we could have these 3D buildings slowly fading in. These buildings look kind of plain, but it's okay. It's less distracting. And we could make the buildings maybe semi-transparent because we are using a 3D editing tool. Anyway, and this square here in the center, that's our MRT station. That is exactly Queenstown MRT station. Right now it looks a bit crude, but imagine that we can play this into a 3D animation, which will zoom into the MRT, maybe do some kind of some kind of panning, some kind of turning around and all that. And the run will start somewhere here, and then you imagine a big purple pinkish bubble dropping into our start point, then a caption that says Queenstown MRT. And that is very good for setting the context. So we know immediately that this is a run that's running, that starts a dense housing area, right? Towards the end of the video, we will show the path of the run. And for information, it starts here, then somehow it goes behind, then it bashes up to the main road. So you just go on and on and on and on. We might show this animated, maybe not, but at least we'll show the trail of dots, of our run. We ran quite a distance. We actually passed this field here, and then went further and further on until we hit the Ulu Pandan Canal. And we're still running and still running and still running. Yeah, there you go. That's the Ulu Pandan Canal. We actually ran all the way here, bashing through all the roads. Then we just ran down the path into the canal. Yep, we ran past this canal. And if you ever run past this spot, you might see some monitor lizards and otters. I saw them quite quickly. And then we kept running and running and running. So this is actually quite nice if we can show this at the end of the video. Maybe a zoom up version, not so detailed. Just to show that we are running around this canal, and this is the kind of area, the kind of neighborhood that we run past. Notice that buildings here are a lot smaller. These are smaller private residential estates. That's why the buildings are a lot shorter. And we keep running, and all the way until we hit the junction. And where is that? Oh, there you go. Yeah. And this is where we got off the canal. We ran here, we crossed over. Then we ran on this side of the canal. This is it's part of the same canal. We crossed over, and trying to find a spot where we ended, which will be somewhere around here. Yeah, this is probably a spot that we ended. Yeah, as you can see, it's going to be quite interesting. We have a 3D version of this map, and we have like little dots in purple pink color, dotting all the way to our final finishing point. It gives you plenty of context about what our run is like. And I might start doing this for our next batch of videos, which is the Sungai Bedok run. Now, how are we going to do this? This will be some kind of it will have to be some kind of guided recording. I will have to program this in Unity, which is okay. I've got plenty of time, and I'm doing C# programming .NET, which I've done before in my previous life. Anyway, I'll be doing the programming so that we can track a path of a flying camera through this running path. The dots, we will. How do we get the coordinates of all the points that run through? We have a record for that. If you remember in our videos, for example, if you pick one of our videos, okay, like, no, not this, but this one. If you go into one of our previous videos, any of our videos, let's say Sunset Way Run, 360-degree video, in the video description, there is a hyperlink to a fit file. If you right-click this, you will be able to see the fit file. What is this fit file? This fit file is a record of my run at Sunset Way. How did we record it? We used the a Garmin watch. I was wearing a Garmin Forerunner watch, and our watch recorded the activity, and from there we can export the activity, which includes the latitude, longitude coordinates. Let me show you how. This is logging into the Garmin Connect portal. This is the web-based version. It will not be accessible. You will not be able to export it through the mobile app. You have to use the desktop, the web browser version of Garmin Connect. Our run was on Saturday. Let's click on that. And we have activity called Sunset Way with SGFR. That was the activity that we ran. And here is the route. How do we get these points here? Easy. Just click this tools icon above. Then click export file. Then it will download a zip file. Just unzip the zip file, and there you go. That's the fit file. What's inside this file? Easiest way to see it is to go into a fit file viewer. Search for fit file viewer, and I picked the first one. This is a tool, an online tool that will allow us to view a fit file. I will just click open fit file, and I will select the fit file from our run, Sunset Way run. This one. Now this is going to be quite raw, but we will see the very raw data, and it's quite interesting, quite fascinating. There is a lot of data that is exported here. Okay, let me see what's in the map. Oh, there you go. This proves that the fit file contains the actual points of the run, where we started and where we finished, right? Okay, it shows us by kilometer. That's fine. Chart. This is my heart rate. Yes, it had heart rate data in there, and cadence is quite interesting. We have it also. Now notice that the cadence data is in RPM. RPM is revolutions per minute, and you notice that it's a bit different from our cadence data that we see in the Garmin Connect app on Strava. That's because cadence in RPM is half of cadence in steps per minute, which is the unit used by Garmin Connect and in Strava. Therefore, to get the normal number of cadence that we see in our apps, we take this number 98 and we multiply it by 2. Right? So it will be close to 190 something, 96, which is quite, which seems quite correct. My typical running cadence is 186. I prefer to run at a higher cadence so that it's better for my knees. It's got less risk of injury. It's up to you. You know, it may work well for some people, maybe not. But for me, 98, sorry, 186 cadence works fine for me. You can also see my run-walk strategy. I will run for a while, perhaps a minute or two, then I'll walk for a minute or two, and so on. I'm getting old. My tendons and my knees are not getting so great. And besides, my cadence is quite high. Therefore, I tend to balance my high cadence with a lot more walking, and that works better for my knees. I can recover faster with this kind of run strategy. And this is what I do for marathons also. I will take 6 hours, yes, but it's going to be quite gentle on my knees with this kind of run strategy. The first part looks very weird because I was starting my watch a lot earlier, but then I paused the recording until I actually started the run. Yeah. Now this is all nicely charted out, but for our own purpose, we will have to take the raw data. And let me show you the raw data, what it looks like. We're looking at through a web browser. For the actual implementation, we will use a tool that will dump out all this data in raw form. That way we can ingest all this data and then plot it onto our 3D map inside Unity. Look at the GPS metadata. It's got 6,500 rows. That's a lot. And there we have it. We can see that I'm going to show. Okay, 50 rows per page is fine. Let me just jump out to the middle. So there's a lot of data. 132 pages. Maybe let's go somewhere into the middle. Okay, fine. That's middle enough. What? Okay, something seems to be missing here. Now, where's our GPS data? Is it here? GPS event is here, which is nothing. Okay. So GPS event tells us that these are the kind of satellites that we use. We've got plenty of satellites here in Singapore. If I go further on. Yeah, for some reason it's not showing up, but I've seen it before. In the past, I've seen. Okay, my mistake. We should look under record. So for some reason, okay, we're looking at GPS metadata. Yeah, my mistake. We're not looking at GPS metadata. It's just it doesn't say GPS data, but it says metadata. That means what about? It's augmenting the data that from GPS. It's adding on, and the thing it's adding on is that it's telling us the altitude, how high we are, and the speed, how fast we're running. But that's not really useful for us. So let's close this. What we actually need is all the way down here. There you go, record 3,000 rows. This is the one that has got everything in it, right? Again, I'm going to zoom into the middle. Okay, fine. As we can see, this is the data that we actually need. It has got the latitude, it has got the longitude. Singapore is at roughly 1 degree north. So this looks kind of accurate. This is where we will plot our running points in the Unity tool. We will take this and we will draw the dots, and eventually it will show us our running path. For info, if you're ever interested in doing any kind of analytics on your own health data, well, we got heart rate here, quite important. Heart rate is pretty high. We got the cadence. Remember that this is revolutions per minute. So normally we'll take this multiplied by 2. So 94 will multiply by 2 to get 188. Right, and that's my typical cadence. The cadence here you see is lower because I'm walking and then I'm running here. Distance from the start point, temperature if you want to know how hot it is. Vertical oscillation, I think less vertical oscillation is better, so we are running more efficiently, I think. Yeah, there you go. Which means that we have all the data that we need. We use a tool to dump this out into a raw format, not a web browser format. But you can see that the data we have inside is for latitude, longitude, which is plenty enough for us to plot our running journey inside our Unity tool or any other tool that you prefer. Now, that's about the fit file. Now let's head back a bit and talk about how I managed to get our Unity tool running. This thing actually took quite a bit of effort to do this. Surprisingly, it's kind of old tool, and there were some support issues. But let me, in case you're wondering, how did we get this map to zoom into Queenstown MRT at the beginning? Well, it wasn't there by accident. We set the map. Over here on the left, we click on map. See this? Inside the map, there's a latitude, longitude. And this is where we put in our coordinates. How do we get this? Well, I went to the Google Maps website, look for Queenstown MRT. Then you can right-click on the pin and it will tell you the latitude, longitude. Let me just do a quick demo. We head over to our Google, web browser here. Search for Queenstown MRT. Then go into Google Maps. Right-click on this. See, this comes up. Then you click on that, and it gets copied to clipboard. And then I pasted it into our Unity development tool. There. Yeah, and that's why when you run this, it will show everything centered at Queenstown MRT. But how do we get this map in the first place? This comes from the Unity SDK, but the instructions for setting up the Unity maps in for Mapbox, the instructions are not quite correct. If you could do a Google search for the Maps SDK for Unity, the Mapbox Maps SDK for Unity, you'll get this page. But there's a huge warning in front. It says that version 2 of the Maps SDK is not in development. It's kind of obsolete. But then again, version 3 is still in development and not ready yet. Then we're kind of stuck. If we continue using version 2 of the Maps SDK, which these instructions are for, it will not work. I tried, it doesn't work. Our version of Unity is the Unity development tool is just way too advanced. Right now we're using 2026 version. It's a free download, by the way, just download and use it. And this Mapbox SDK is also free, just use the free license key. But version 2 will not work with the latest version of Unity development tool. We have to use version 3, but version 3, it's not quite clear. The instructions are not here. If you try to follow the instructions, it will talk about version 2 of the Unity package for Mapbox. If you try to follow these steps, it will not work. It will fail. So do not ever follow these steps. The right way to do it is head over to GitHub, look for the Mapbox Unity SDK. This is the source code for the SDK that will render Mapbox maps inside Unity. So essentially, this is the source code version of all this. If you search to this website, you will be able to scroll down and you can see these instructions. Right? It says that you need to clone or download the SDK, which means hitting up here, then code and download zip. Right? That's the typical way we download the SDK. Use the Unity package manager, import the package which means selecting the package.json file. And then it should appear. But then again, I also had some issues. I think the Unity API has changed in recent versions. Some of it didn't quite work correctly. I don't have it here, but you run into some issues, and you will see them when load in. When you see those messages, just Google for them, and it will provide the fix. It will tell you what to fix. Like for example, some of the things I fixed here, like for example, mesh ID used to be an integer. In the new version of Unity as the API, it now becomes an entity ID. I had to go in to fix all these C# code. This will allow us to compile the SDK correctly, and it will run, which is what you saw. There are a few things to fix. Yeah, so watch out. Can I see the rest? Yeah, I'm trying to recall what I did, but there are a few things that we changed. It was quite messy. Right, and then after that, we need to put in the access token. If we go into the, you can get a token at the Mapbox account page. Anybody can register for your free account at Mapbox. Just get a token and paste it into the Mapbox setup inside Unity. Then I use a sample demo scene. The one I use is Mapbox World Map Viewer, and this is what we get when we run it. Yeah, there you go. This is our Mapbox viewer. How are we going to record this output? There is a tool for doing that. The tool is called, if you look at the, if you search for Unity Export Video, there's something called a Unity Recorder. It will allow you to click a record button, and it will render in high resolution a output of the graphics, the animation that's currently playing. And that's how we will capture our Unity user interface, our Unity video output, our rendered 3D, into an MP4 format by using the this Unity recorder. Right? And hopefully it will be a lot smoother than what we saw earlier on. Of course, we need to program in the flying camera. We will need to implement a flying camera in Unity so that we can automate some of these sequences. It will fly through the places of interest without us having to control them, right? And it'll be a lot smoother. We might probably have to record a few times, maybe one with just the base layer without the buildings, a second time with the buildings, and maybe a third time with our big blob of purple pink dropping into the start point. Yeah. There. One more thing I should talk about. I briefly considered exporting Mapbox from Unity into a 3D format like FBX. I followed the instructions here, and then I went into Unity and I did a right-click export to FBX. This requires a special plugin to be installed. Once we do that, we will get a 3D file, like a 3D object model of this whole thing. Whoa, okay, start spinning. Escape. Okay, good. But the problem with this 3D file is that, let me show you what happens when I load the 3D file. Okay, well, in the first place, why do I want a 3D file? Well, that's because I'm editing the video in Adobe Premiere, and there is a companion tool, Adobe After Effects, that is great for doing motion graphics, especially this 3D fly-through and stuff. But when I exported the 3D model, FBX format from Unity, and I use a FBX viewer to load it and view it, you see that it's really quite dull. It's underwhelming. This is the Queenstown MRT station. but it's not very pleasant because it doesn't have the base layer. The satellite map is missing. There's no context at all what this thing is. The rendered buildings are also quite dull. Yeah, everything's all grey. It looks nicer here with the textures and all that. That's why I've decided that exporting to FBX and rendering in After Effects is not probably a good idea. We will do a lot of effects in After Effects to do this rendering in a nice way. Therefore, I'm deciding to use the Unity development tool to automate some of this camera fly-in by using some C# scripting, and then running the Unity recorder to record the output of this 3D rendering. That seems to be the easy way to do it. Yeah. Then I have another problem. How do I seamlessly blend this rendered 3D output into my video, right? Our video has all this sky thing here. It's gonna look very weird if this thing just plonks on top of it. I have some thoughts. I might have to do some kind of a blur effect on the top of this video, in a way that this bottom part, which we want to retain, will slowly blur to white. Then I will chop off the top half of this image and paste it into Unity to be rendered as a background, which means that we will probably not see the sky, we will probably not see the distant landscape. In fact, I'm hoping to show maybe just one small square that will look nicer when we rotate it in the rendered 3D map. Imagine everything fitting to a square, and everything outside the square will be the blurred background of this video in white. Then after rendering, I'll just simply superimpose and overlay it on top of this video, which might look nicer, right? Same thing for the end of the video. We will do a fade to white at the top with some blurring. Then I will take a snapshot of this top half of the video frame, load it into Unity for rendering as a background. And again, we'll chop off only the relevant bits. This is a bit too much detail, too many buildings. I'm trying to see how I can fit only part of this here. Right, so that was a long discussion about rendering our running maps inside our videos by using the Unity development tool and also using the Mapbox SDK for 3D buildings. It's going to take a while to develop this, but then again, I have plenty of time. Maybe after I've complete editing the videos for Sunset Way, I will do some time on this. The good thing about this is that I have plenty of time to prepare for this. Our run for Sungai Bedok it's on Saturday morning. Today is only Tuesday morning, which gives me plenty of time to experiment. Will it be ready for Sungai Bedok? Not sure, but we'll try it. And again, we'll use this experiment to see if users, our viewers, get engaged. It's quite important to engage our viewers right at the beginning of the video. Maybe a 3D animation will be at the beginning of the video will be interesting. Another 3D animation at the end of the video to keep people watching towards the end might be good. Yeah, maybe not. But in any case, it's a good exercise for me. It's a good mental exercise to do all this programming. Get used to this Unity tool, which is quite new to me anyway, and figure out how to do these fun things within this 3D development tool. Yeah, and I'll update this in the next live stream. But for today's live stream, we'll go back to our editing of video for Premiere Pro. We have created the first part of our Sunset Way running videos. Now we will create the second and last part. The first part was kind of the first part of the video was kind of edgy, kind of trippy, kind of very distracting, very quick, very energetic, high energy, with lots of quick cuts and flying through landscape and all that. The second part will slow down. we will focus more on the social aspects. Yes, we will keep a few of these clips from the earlier video into the next video, but the rest of it will focus more on the social parts. What I mean by social parts is that we had a cool down exercise at Sunset Way. We will show more of that, and we have some shots of okay, that's the cool down exercise. We have some shots of us at the local eatery having brunch. We will have that too, right? Yeah, and that's how we plan to execute our second video. We're showing more the social aspects. Singapore front runners is not just about running, but also the social parts. And also this is a good way to remember all the members that join our group. We'll see lots of faces here that we will remember in this video for many years to come. Let's begin our video. Now, in the previous video, we realized that one very good thing that we did was that we created the music before editing the video. That way, we are able to place the music, the beats on the music, and synchronize them precisely with the video. So everything is all smooth and everything is all in sync. It looks very nice. Therefore, for today, we will also create the music before we edit the video. And that's our focus for today. Creating the music for the second video of the Sunset Way run. If you recall, the way we did music is that we use this Logic Pro tool, which will split our music track into vocals, instrumentals, and so on. The reason for doing that is that we will import all these individual tracks into Premiere, and we will tweak the vocals. There are some parts we don't want vocals. We will use the Premiere tool to do that. Let's go through the same sequence. We start with an empty project, choose. There is a space in front. We will drag and remove the space. Now we will do the stem splitting. This is the splitting of the vocals and the instrumental tracks. Right click, processing, stem splitter. And yes, we will split by vocals, drums, instrumental, and so on. Just click apply. And it's splitting now. Right, in a while we'll see different tracks. We'll see a track for vocals, we'll see the tracks for bass, drum, and all that. We will import these tracks into Premiere individually, but I'll show you in a while how we do that. Let's wait for this to complete. Okay, let me just do a quick check to make sure that our stream is still running. Okay, good, still running. Head over to our Logic Pro. There. These are the tracks all nicely split out. We have vocals, we have drums, and all that. Let me just do a quick preview. Muted? Unmuted. Okay, so we heard that the vocals are very well separated, so that's good for us. We want to be able to tweak the vocals. What about other tracks? Drums. Cool. Drums are also okay. There is bass that's coming on here. Let's. We have the guitar. Okay, there isn't much piano in this song, and the other is quite clean. So it's quite different. You notice that the separation is cleaner. We will see it, we will actually see the drums, the bass, the guitar, maybe a bit of piano. And the other track, all the other sounds that Logic Pro couldn't identify, it's quite minimal. This is very different from the earlier splitting that we did for the Blackpink Go music for the previous video. The reason for that is that the previous audio, the previous song, Blackpink Go, it's very much pop EDM like. Everything is all heavily processed. This is typical of K-pop. It's very heavily processed. Everything is all synthesized. We don't hear any real instruments for bass, guitar, and all that. Everything gets lumped into other, which becomes quite messy, and the other tracks become quite empty. And today we have a refreshing break. Everything is more traditional. We can see that real instruments are being used for drums, bass, and guitar, and that's why it separated the instrumentals quite cleanly. So in fact, if we wanted to remove the bass and the guitar from this song, we could. Everything is well separated. We couldn't do this with the earlier music for Blackpink Go because everything is all meshed up in other. Right? Yeah, this is it proves that the Logic Pro really works for separating traditional instruments, but not so much for separating synthesized, heavily processed music. Now, we're going to import all these tracks into Adobe Premiere, but first we will export them into a WAV file to allow the export to happen. We click File, Export, all tracks as audio files. I'm going to put it into the Video 360 folder. And yep, just these are the options that we use, and export. And we're done. Now we can go back to Premiere and import the audio tracks. Okay, before that, let's do some cleanup. We have a lot of run. This is our Premiere project. We have a lot of run videos in here. Let's just clean up. Maybe I'll just put everything into a run folder. So we saw in earlier live streams that we created all these runs. Let's clean them up. New bin from selection. We'll just simply call it run. And let's clean up. This can all go into warm up. Right click, new bin from selection. Great, everything is much tidier now. And now we can put in our music. I'm going to right click, import, and select all the WAV files that we splitted earlier. We do not need stems. All we need is other, and everything else up to vocals. Import. Now I'm going to close all this because I don't think I need them for today. Alright, if you remember our sequence from earlier, we will create a new audio sequence based on the vocal track. The last track is the vocals. I will just right click and select new sequence from clip. This will create a new audio sequence that has the exact same audio settings as this clip. Let me just resort just to be sure. Yeah. I will rename this as Part 2. Okay. Resort again. Okay, Part 2 is there. Now we can add in all the other tracks by dragging and dropping them, but we don't have sufficient space. To make space, we will create extra tracks. I will need altogether 6 tracks. Right now we have 3 tracks, so let's add in 3 more audio tracks. 3. Okay, good. We're done. So this is our vocals. Let's just drag in our other tracks into this music here, this sequence. First one. Okay, we had this problem where things were not properly parked in the left. I think it's because we didn't zoom in enough. Let's just zoom in nicely so that we know that it's really, really at the left. Second, the piece, then next. It's very important to park everything right at the left. Don't leave any gaps. And last one. Okay, let's verify and listen to the preview. Okay, good. We know that the audio and the drum tracks are in sync, but what about the bass and the guitar? Okay, great. Everything's in sync. I'm just curious, what is this at the end if I solo it? Okay. I think it's like a bass piano. It's fun. Okay. Okay, we have everything all separated. Now maybe we will look for interesting point to include in our video. The way I'm doing this is that I'm looking for a pre-chorus and a chorus section of the song. Something that people will recognize. We will choose only a 30-second segment of the song because we don't have a lot of time. And we might speed up like by 10% or 20%. That way we can have more of the song to play in our video. Now, how do we find the pre-chorus and the chorus? Let's see. Okay, cool. By looking at this bass guitar track, we can see that something interesting is happening here, and that happens to be the pre-chorus. Okay, how long is this? This is the beginning of pre-chorus, 31. The chorus, okay, goes on for at least 30 seconds. Oh, okay, actually 30 seconds. Right, so if I want to use this entire clip in my video, we only have enough time for the pre-chorus and the chorus. Not even enough time for the verse before and after that. My strategy right now is that we will begin a song around the pre-chorus, but we will maybe mute out some of the vocals. Okay, let's try that. Okay, we don't want to mute out too much vocals so that it sounds really weird, but let's try and do it in a natural way. We know that the pre-chorus begins here, right? What I'll do is that I will adjust the volume of the track. Let's zoom in a bit further. Okay, I'm going to go into the volume here and set a keyframe. Okay, eventually I'll set this to 0, but just before the pre-chorus, I'll set it a keyframe again. Okay, which means that for the earlier keyframe, I'll bring down the level to 0. That way we muted everything in front of the pre-chorus. Okay, good. That's actually a lot of vocals. Maybe I'll try to mute this in a while, but let's isolate the pre-chorus and the chorus. We have the pre-chorus here, it stretches all the way out. Then we can see this. Oops, do we see? I'm looking for the pattern in the bass guitar. Yeah, the pre-chorus ends here. The chorus begins here. Where does the chorus end? Okay, the chorus ends here. Let's put a keyframe here and slowly fade out. Here. Okay, so now I can drag this all the way down. Okay, too much, too soon. Axis. Oh, there's another way to do this. Just drag here. And okay, it's kind of weird. It's just this is still weird. Yeah, I'm trying to make it less weird. Let me just move. Oops. Try this. Okay, less weird. Now, there's gonna be a lot of vocals here. Right now, we have ending at 1 minute. The starting point of this is at 30 seconds. So this is definitely too long. It's okay. We're gonna have vocals all the way through. Now the trick is to figure out which parts of these vocals can I mute up. Okay, there are two parts of the pre-chorus. Maybe I can mute the middle part of the pre-chorus. The first part of the pre-chorus, and we just keep only the second part of the pre-chorus. So there'll be some instrumental in front, then we introduce the part of the pre-chorus, then followed by the chorus. Let's try that. The pre-chorus first part ends here. Okay, somewhere here. Put a keyframe. I'm going to keep the earlier keyframes so it's good for my reference. I'm going to move it a bit. Okay, this is going to be quite tight, but let me try. Because you see this little gap here, so that's where the first part of the pre-chorus ends and the next part begins. I could put a keyframe here, maybe move, or maybe not. Okay, what if I just leave it like this? This goes all the way down. Okay, let's play again. Now the first part of the pre-chorus should be all muted. Okay, this is good. The reason why we muted just half of the pre-chorus is that if we start the video at this point, it gives kind of, leaves our viewer guessing. It sounds familiar, but we're not sure what this music is. So we hear the first part of the pre-chorus without the vocals. It sounds kind of fresh, sounds kind of interesting. And then we won't discover what this piece of music is until the vocals come in here. Yeah, because we don't really need to hear the whole part of the pre-chorus again. The aperture song is a bit overplayed already. We're trying to give a fresh new interpretation, a fresh new perspective on the song. And we do that by muting the first part of the pre-chorus. And hopefully nobody has heard that before. Okay, good. Now I'm going to see what's the effect of speeding up this clip. The pre-chorus, I don't actually have to start the whole pre-chorus. I can start it somewhere here. So it's at 34. Now I'm going to, remember what we did with the Blackpink Go and the quickening part? We wanted to speed up the video, so speed up the audio so that we can feature more of it into the video. We'll do the same thing. We will right click, we will say select new sequence from clip. This will take the audio we created earlier on and wrap it into a new sequence. And the same thing, we'll do a quicken. We said that we will truncate, we will chop it off at 34. Let's do that. Next, zoom in a bit. And we will start at 34. Just drag until we see plus 34. Okay. Is this a good place to start? Okay. Delete this. So this is an interesting 5-second intro that we have, which is quite similar to our earlier video. Okay, I think that's good. 5 seconds of no vocals. Yeah, but the starting point is a bit odd. Maybe just shift it a bit. Okay, good. This is a more logical starting point. Now we will speed up the clip. We will do a right click, speed duration. Okay, if I really want to have more of this song, I can speed it up even more. Let's say 120%. We tried it last time with Go and it wasn't so great. Everything sounded like chipmunks. Maybe this will work better. Let's try. Yeah, there you go, the chipmunk effect. Speeding up by 120% is not good. We will just simply speed up by additional 10%. Hopefully it will pitch up a bit. It will play the music a bit faster and it won't have that chipmunk voice. Okay, that sounds kind of okay. It's faster now. Now I'm trying to figure out where it ends. Suppose our video is at 30 seconds. How much of the music will we get in? Okay, quite interesting. So we actually go into the next verse. Might be a good thing to do. Which means our audio will end up around here. Let's just trim it. So our audio will be 33 seconds long. But there's kind of too much of the verse maybe. We have like 3 seconds of verse. A bit too long maybe. What we can do is that maybe we can allow more of the pre-chorus. Okay, let's tweak this part and we will play more of the pre-chorus. Extend it by 1 second. Okay. Sounds a bit strange, but okay, we can tweak this later. So our music clip is like 35 seconds now. We can probably reduce this. We don't need so much vocals from the verse. Okay, I'm hearing some distortion in audio, probably because our audio source is not really that high quality, and therefore the splitting of the stems is not so great. But this might be good enough for now. Okay, good. This will do fine for our music right now, and we are done with the music for our next part of the video. Yeah, so today's live stream was a bit longer than usual. We started off by talking about the 3D maps, how we might use 3D maps in our video to make it more exciting. We will have a fly through to our starting point, which is at Queenstown MRT. And we will be doing some programming inside Unity, the Unity development tool, to do this fly through. We'll also be plotting the path of our run. How do we get the data, the latitude, longitude coordinates? We have this tool. We have the FIT, the fit file. It records the latitude and longitude points, so every single point in the run. Therefore, we will extract this data using a fit tool. Once we have extracted the latitude and the longitude data, we were able to put this data back into our Unity project and render them as points along the path. Then we will render this with the right background, and we will overlay this onto our video. We will have this at the beginning of the video to show the starting point. We will have it again at the end of the video to show the running path as well as the finishing point. And the reason for doing that is that we are trying to get rid of the skies. We have still too much sky in the video. Maybe it will make our sky more interesting if we use this to put a map on top. Then we talk about creating the music for the next part of the video. We use Logic Pro to separate the music, which is Apache by Rose and Bruno Mars, into separate tracks: vocals, drums, bass, guitar, and so on. Then we imported all these tracks into Premiere, and then we did some layering and some manipulation of the vocal track. We cut off the first part of the pre-chorus, we left the second part in, and we left out most of the chorus and tuning out slowly for the next verse. This will hopefully give our viewers a new version of Apache that they haven't heard before, and make it sound a bit more refreshing instead of the same old boring stuff that they heard so many times before. Yeah, that's it for the audio for our new video. In the next part, we will start actually editing the video for part 2 of our Instagram reel. Please join me in the next live stream. If you're looking for next live stream, I'll leave the link in the video description below. Thank you. Bye.